All right, so two things today: graphing logs, which we've already kind of touched, and then the properties of logs and solving equations. So we'll hit the graphing part. Basically, we're going to change it to an exponential and graph that exponential, which you guys know how to do. But I'll go over it just in case you're confused, so you're not confused. The big thing today is properties of logs and solving equations. So, write that as an exponential. What's the base? 3 exponent y equals x plus 1. Okay. These ones is easier to actually work backwards. Okay, so what's a y value? And then go get the x. That's the only change. I would start with the y, go get the x. Okay. So for -2, we have 3 to the -2 equals x plus 1, right? Yeah, 1 over 9 equals x plus 1. What is x? 1/9. Okay, you can write that as 9 over 9. What's 1 minus 9? It's -8 over 9, right? And do the same thing for the rest of them. This one's -2/3. 0, 2, 8. So which one? Y is 0? Okay, what's 3 to 0? 1 minus 1. This is gonna solve for x. So. Huh? No, I didn't. Wow, that was way off. It's a good thing I'm writing in pencil, right? So I have been corrected. My curve is not quite accurate. Is that better? Okay. So you think you can handle that? Write it as an exponential graph like you used to. Yeah, pretty much. Okay, that's where we're going. Okay, the properties of logs. Much like properties of powers. Remember when we did game day last week? Monday, Tuesday?
Yes.
And we generated the properties of powers on the board. Same deal for logs. Okay, so if I have something like log base BMN, it's multiplied. You can change that to addition with them separated. I would relate it much to that properties of powers rule right there. Remember, multiply the exponents with like bases means add. It's the same thing. Does that make sense? So we're comparing it to those. What do you think the quotient looks like? What was that one? M minus n, yeah. So we have the same thing here. Where you subtract them. Okay. The last one is kind of, it gets people, right? It's kind of, it's counterintuitive. Okay, this is log base b m to the power of b, of p. It's a power. Well, I put it there, my pencil. Why? Because this is a property of logarithms. It's very useful. It equals p times log b m. You can bring it out front and multiply. Okay. It's kind of screwy. It doesn't seem right, but it's a rule of logarithms you can use very readily. Right. There's not a power rule we can relate it to, so it's just something you have to know is true. Okay. Just trust that it's true. So, I mean, we could go through and derive it, but I don't think it would be beneficial. So, we're going to use these and the definition of logs to solve equations. All right. So, let's solve an equation. If you have, see the base is the base here is the variable. Best to rewrite it as an exponential. So p to the 1/2 is 64 to the 1/3, right? One way to solve an equation, rewrite it as an exponential. What's 64 to the 1/3? The cube root is 64. 4. Okay. How do I get rid of the 1/2? Yeah, square both sides. So p is no.
Declare it. Come on, man. Okay, very doable, right? Okay, here's another one that's pretty doable. This is a property that I didn't point out, like explicitly, but basically, yeah, they're the same log on both sides, base 4, right? So basically, I wouldn't say they cancel, but one of the properties of logs says that this is true. Can you solve that equation? Lord, I hope so. What is that? It is. You're right. So add 4 minus 2, x is 5. Okay. So far, are you okay with that? Okay, the next one is going to use the properties a little better. It's going to be a little harder, though, at the same time. Let's solve log base 11x plus log 11x plus 1 equals log 11, 6. Cool. You can't yet. See the addition sign? Yeah, it's messy. So, but if I want to get to that point, well then, what can I do with these two? And what does it give me?
Log 11x squared.
You're thinking on the right track. Log 11, x times x plus 1. So the property says, if those are added with the same base, I can multiply these together in the same one. These now can be gone because they have the same base. Yep. You're way ahead of me. And then distribute. And solve the quadratic. Yeah. I know. Yeah, we'll just break the journal.
Yeah.
That one's actually, I believe. Try to solve it. We've done this so many times. Try to remember how to factor. So, yes. Right? Positive 2 and negative 3 are your x values for x. No, because it has to be positive 1 when you add them. 3 minus 2 is 1. Got it. Okay. Do you want to see another? Or do you think you're okay? We'll give it a shot. Okay, they do get more difficult, but we'll just see how you do. If you need help, you've got 25 minutes. That's why I wanted to give you some time. Just let me know. Did I give you all of it yesterday? If you were gone, there's what we did yesterday. Here's today. And then the review. Right there. Do tomorrow.